Okay, good morning. I'm going to go over how to set up a two-cylinder configuration for a two-dimensional flow for laminar conditions. So let's go to COMSOL. We're going to go to the model wizard, 2D. Now, fluid flow, single phase, laminar. Add it. Hit study, time dependent, done. Now we're going to go to our parameters tab. We're going to rename this geometry. We're going to have our first variable D. It's going to be the diameter of the cylinder. Width is going to be 25 times the diameter. Height is going to be 17 times the diameter. And the placement of the inlet is going to be 5 times the diameter plus the length. And we're going to define the length later on. So let's make another list of parameters. So we'll call this second cylinder. So we're going to have a D ratio. We're going to set that equal to 1. And then we're going to have our lowercase d. It's going to be the D ratio times diameter. We're going to have a length ratio. And we're going to say that the length ratio is going to be 2. And that makes our length a length ratio times the diameter. Now we also have this angle alpha, which we're going to say is 30 degrees. And finally, we're going to give the average diameter as the average between the two diameters. Okay. Next, we're going to make a parameter list for the flow. So we're going to have Reynolds, and we're going to make it around 300. Actually, I'll make it, 300 is good. 300 is good. Now, let's define the density. 1,000 kilograms per meter cubed. And the viscosity, 1 e to the minus 3 Pascal seconds. Now our velocity is going to be the Reynolds times density, times the viscosity, divided by the density times the average diameter. Okay. Very small velocity. Okay. Now let's make a new tab here. We're going to call it time step. We're going to guess our Struhal at 0.5. We're going to guess our shedding frequency as the Struhal guess times the diameter average over the velocity. Sorry, I got that backwards. It's the velocity over the average diameter. Now our shedding period is going to be 1 over F. Yes. Now we're going to define a variable n, E10. And we're going to say that our delta T is going to be T guess over n. Now we're going to have a number of shedding periods, 100 shedding periods. And we're going to say that our final time is going to have 100 shedding periods. Okay. Now let's make a new parameter called boundary layer. And we're going to define the boundary layer thickness to be 0.1 times the larger diameter divided by square root parameters. Okay. Perfect. Now let's go ahead and find another parameter, and we'll call it start time. Start time is going to be time is t. This can be the width over velocity plus 0.25. Okay. Next, we're going to make function, step function, 0.1, plot it. So this step function is used to ramp up the velocity in the flow, and we'll see that later on. So now let's go over to geometry, and let's create a rectangle. Rectangle will have a width of W, height H. The X placement will be at negative CX, and the Y placement will be negative H over 2. Okay. Now let's make a circle. We'll have diameter D at 0, 0. Then we're going to make another one. Oh, actually, here, it's D over 2. Apologies. Okay, now let's go ahead and make another circle. And now this is going to be lowercase d over 2. And this is going to be placed at L times cosine alpha. And then L times sine alpha. Okay, let's build all the objects. Now let's make a Boolean operation. Okay, so the objects to add are the rectangle, objects to subtract, these two circles. Perfect. Now go to material, length material, density, plug it in. We'll put in the viscosity as well. Now we can go to laminar flow. We're going to define our slip conditions on the top and bottom wall. Now let's define the inlet. Place the inlet right there. Say it's the free stream velocity times step function. Then you input time, and then you do 1 over seconds. Then you close that out. We also need an outlet. We're going to put an outlet on the other end. And then we'll move to the mesh. We're going to make it an extra fine mesh. Build that. Now we're going to go to user controlled. We have a finer size and extremely fine on that size. Now we're going to boundary layers, boundary layer properties, and the thickness of the first layer is going to be that variable that we assign B, L, T. Now, to build it, we're going to go to study 1, show default solver. Expand this section, go to time dependent solver, time stepping, and instead of free, we're going to choose intermediate so that the solver will choose time steps in between our output time step. Okay, so now let's go to time dependent and let's define our time step. We're going to say range 0, 2, time start minus 0.2, and then range start time delta t, and then time start plus thin. Let's go to study 1, and we're going to turn off generate default plots. Now we're going to go to results and go to 2D plot group. And for this, we're going to right click 2D plot group, go to surface. And instead of rainbow, we're going to use wave classic. For the range, we're going to put manual range of -1, 1. And for our expression, we're going to go to laminar flow, velocity, vorticity. So we're going to do the vorticity in the Z direction. We're going to multiply that by the average diameter and divide by the velocity. Okay, perfect. Now we can go ahead and save this study. We're going to save it as Reynolds 300 2-cylinder base. Now we're going to do save as, and we're going to have our run model. Now let's go ahead and compute this, and then we can look at our results. Okay, so here are the results. Let's save this image. So we'll go ahead and press this button. And then we're going to go to browse. And we're going to say vorticity, Reynolds of 300, 2 cylinders. Save. Perfect. Now let's just save that. And next we're going to export the pressure probes over time. So let's P, we get the pressure, And let's choose the file name. Let's do a gridded array. So we're going to do W over D times 2. And then we're going to do H over D times 2. So then we have a proportional grid of probe locations throughout the domain. Now let's go ahead and export this. So we can copy this and we can change this to 300. And we'll hit save.